Hello students, in this part we will learn types of chemical reaction.
Life is beautiful, isn't it? Presence of oxygen makes life possible on Earth. But how this oxygen reaches to each and every cell of our body? Oxygen combines with hemoglobin to form a complex called oxyhemoglobin. This is an example of combination reaction. Let's go further and learn more about combination reaction. In a combination reaction, two substances react to form a single product. For example, in general, A reacts with B to form a single product AB. Notice here the product formed is always a compound. For a combination reaction to take place, the reactants could be a combination of two elements, an element and a compound, or the combination of two compounds. Let us perform an experiment to observe the combination reaction between quicklime and water. For this, take small amount of quicklime in a beaker. Now, slowly pour distilled water into the beaker. Notice, a large amount of heat is produced in the reaction. Now, touch the surface of the beaker. What do you feel? The surface of the beaker becomes hot due to the evolution of heat. The reactions in which heat is evolved are termed as exothermic reactions. Now, leave the beaker undisturbed for some time. You will notice a clear solution of lime water is formed as the white precipitate settles down at the bottom of the beaker. Do you know the name of this white precipitate? It is slaked lime. Now, take small amount of clear solution of lime water from the beaker into a test tube. Blow the exhaled air into the test tube containing lime water and observe. Notice the lime water turns milky due to the formation of insoluble calcium carbonate. Let us understand combination reaction by considering another reaction where iron reacts with sulfur. Take iron filings and sulfur in a china dish. Mix them and heat the mixture. Did you observe any change? Yes, on heating the mixture, it gets converted into a black solid substance. This black solid substance is iron sulfide. Thus, iron combines with sulfur to form iron sulfide. Let us see some more examples of combination reaction. During burning, carbon reacts with oxygen to form carbon dioxide. When magnesium is burnt in air, it combines with oxygen present in air to form magnesium oxide. Formation of water from hydrogen and oxygen. Magnesium nitrate is produced from the reaction of magnesium and nitrogen. In a combination reaction, two or more reactants combine to give a single product, while in a decomposition reaction, a single reactant decomposes to give two or more products. Can you find any relation between these two reactions? Yes, combination and decomposition reaction are reverse of each other. When you say Darjeeling, two things come to mind, the tea gardens and the toy train. This toy train has been accorded the UNESCO World Heritage status. While running on the track, it offers breathtaking views of the mountains and valleys. But have you ever observed the track on which the train runs? Notice it is not continuous. In fact, the railway tracks are made by joining small units by thermite reaction. In this reaction, aluminium is made to react with processed iron oxide, forming aluminium and molten iron, which joins the two units of railway track permanently. Aluminium replaces iron in ferric oxide to form aluminium oxide. Therefore, it is a displacement reaction. Let's go to the laboratory and perform a simple experiment for better understanding of displacement reaction. Take an iron nail in a test tube. Add small quantity of copper sulfate solution in it and leave it for a day. Observe it next day. Did you notice any change? The blue-colored solution of copper sulfate changes to light green and a reddish-brown layer of copper is deposited on the iron nail. It happens because iron is placed above copper in the metal reactivity series. and is more reactive than copper. Iron displaces copper from copper sulfate solution. Here, we have observed that the product of the reaction between copper sulfate and iron are iron sulfate and copper. So, what all information can you gather from this activity? Displacement reaction is the reaction in which an element displaces another element from its compound. So, now you have understood what displacement reactions are. Can you predict which of the two reactions would occur? The first one, where lead reacts with a copper chloride solution, or the second one, where copper reacts with lead chloride solution. Out of the two reactions, first reaction would take place. But on what basis we can decide which metal would displace another metal from its compound? The answer is reactivity series. Reactivity series of the metals is the arrangement of the metals in a vertical column in the order of decreasing reactivity. So, metals which are placed above in the reactivity series displaces another element from its compound which is placed below it in the reactivity series. Now you know about the reactivity series. Predict the products formed in the first reaction. When lead is made to react with copper chloride solution, lead chloride and copper are formed. It means lead has displaced copper from its salt. Whereas in the second reaction, copper cannot displace lead from lead chloride solution as copper is less reactive than lead. Let's understand in depth about the displacement reaction by performing an activity. For this activity, we need test tubes, zinc granules, and dilute hydrochloric acid. Take few zinc granules in a test tube. Add small quantity of dilute hydrochloric acid in it. What did you observe? The bubbles of gas start coming out. Let us identify this gas. Take a lighted candle near the mouth of test tube. You will hear a pop sound indicating the presence of hydrogen gas. Zinc is more reactive than hydrogen and it displaces hydrogen from dilute acids. This is a single displacement reaction. Some other examples of displacement reactions are reaction of zinc metal with copper sulfate solution, reaction of zinc metal with dilute sulfuric acid, reaction of iron metal with dilute sulfuric acid. So far we have seen that a metal has displaced another metal from its compound. Can there be a reaction in which two metals or ions displace each other from their compounds? Yes, these types of reactions are called double displacement reaction. Let's study about double displacement reaction. Let us understand it with the help of an activity. For this activity, we need test tubes, barium chloride solution and dilute sulfuric acid. Take a small amount of barium chloride solution in a test tube. Add few drops of dilute sulfuric acid. Did you notice any change? On addition of dilute sulfuric acid, the barium chloride solution becomes turbid. Notice a white precipitate of barium sulfate settles down at the bottom of the test tube. In this reaction, barium and hydrogen ions exchange their position from their compounds. So, we can say that in general, double displacement reactions are those in which two different atoms or group of atoms or ions are exchanged. Reaction of magnesium oxide and calcium sulfide is another example of double displacement reaction. Magnesium sulfide and calcium oxide are formed in this reaction. Now, can you predict what would be the products when silver nitrate is made to react with sodium chloride solution? Of course, silver chloride and sodium nitrate. Displacement reaction is used in the steel making process. In this process, iron is extracted from its ore by heating it with carbon. Double displacement reaction is used in the preparation of salts. Do you know neutralization reaction is a type of double displacement reaction? Observe carefully the reaction between hydrochloric acid and sodium hydroxide, and you will understand. In this reaction, hydrogen and sodium ions exchange their position from their compounds.
Reaction.
Safety is a primary concern whether it is at school, at workplace or at roads. So, keeping the road safety in mind, government is all set to make airbags a compulsory fitment in all cars in coming years. Airbags are very important equipments as they inflate immediately when hit by a hard surface. Do you know from where the gas comes to inflate the airbags? Well, there is an interesting chemistry behind this. Airbags contain sodium azide, which decomposes into sodium and nitrogen gas by absorbing heat. This nitrogen gas inflates the airbag. Can you predict what type of chemical reaction is this? Well, it is a decomposition reaction. Let's know more about it. Decomposition reactions are the reactions in which a compound breaks up to form two or more simpler substances. Just think about it once. How a compound which is stable can decompose? Using a hammer or some sort of energy or what? Well, for a decomposition reaction to occur, heat, electricity or light energy is required. Since it requires energy, or we can say that energy is absorbed, these types of reactions are called endothermic reactions. The decomposition reactions where heat energy is required are called thermal decomposition reactions. Let us now take some examples. Let's begin with the decomposition of ferrous sulfate, for which we require burner, boiling tube, spatula, and ferrous sulfate crystals. Take a small amount of powdered ferrous sulfate in a clean boiling tube with the help of spatula. Heat the boiling tube on a low flame using test tube holder. Now observe the tiny water droplets near the neck of the boiling tube. Also, the color of the salt changes to white. Keep on heating the boiling tube. After some time, you will see that white colored solid changes to a brown colored solid. This brown colored solid is ferric oxide. Now smell the evolved gas by gently wafting it towards your nose. You will observe that the gas smells like burning sulfur. Here, one substance, that is ferrous sulfate, is splitting up into three substances: ferric oxide, sulfur dioxide, and sulfur trioxide on heating. So, this is a thermal decomposition reaction. Let us demonstrate one more experiment to enhance the understanding about decomposition reactions. For the decomposition of lead nitrate, we need burner, boiling tube, spatula, and lead nitrate. Solid lead nitrate is white in color. Take a small amount of lead nitrate in a boiling tube. With the help of test tube holder, heat the boiling tube on a burner. Observe the changes carefully. The color of lead nitrate is changing from white to brown. You can see that a brown gas is coming out from the boiling tube. This gas is nitrogen dioxide and it is a poisonous gas. Bring a glowing splinter over the mouth of the boiling tube. We will see that it catches fire and starts burning again. It shows that oxygen gas is also evolved during decomposition of lead nitrate. Remove the boiling tube from the burner. You will see that the brown color of the salt fades away and the intensity of the brown gas also decreases. On heating the boiling tube again, the color of the salt changes to brown and the intensity of the brown fumes of nitrogen dioxide also increases. Here, one substance, that is lead nitrate, is splitting up into three substances: lead oxide, nitrogen dioxide, and oxygen on heating. So, this is a thermal decomposition reaction. Another important example of thermal decomposition reaction is decomposition of calcium carbonate or limestone, which results in formation of calcium oxide and carbon dioxide. Let's now quickly move on to an example where electricity can cause the decomposition of a compound. Yes, you heard it correctly. Electricity can also cause decomposition of water into simpler components. This is known as electrolysis of water. Electrolysis refers to the usage of electricity for decomposing a substance. In the given chemical equation, water is breaking down into hydrogen gas and oxygen gas when electricity is passed through it. Let us understand the process of electrolysis. The apparatus required for performing the electrolysis of water is called the Hoffmans Voltmeter. The Hoffmans Voltmeter consists of three joined upright tubes. The inner tube is open at the top to allow the addition of the electrolyte, which is the acidified water. The two outer glass tubes are connected to a platinum electrode. These electrodes are connected to the positive and negative terminals of the battery. The electrode connected to the positive terminal of the battery is called the anode, and the electrode connected to the negative terminal of the battery is called the cathode. When the electric current is passed through the water, it dissociates into hydrogen ions and hydroxyl ions. Observe the slow evolution of the gases. At the cathode, the positively charged hydrogen ions get discharged as the hydrogen atoms that form the hydrogen molecules. At the anode, the negatively charged hydroxyl ions are discharged that form water and oxygen gas. Each of the two gases displaces water and gets collected at the top of the two outer tubes. Now, observe the volume of the gases released at the two electrodes. You will notice that the volume of the hydrogen gas released at the cathode is double the volume of the oxygen gas formed at the anode. However, how will we confirm that the gas released at the cathode is hydrogen gas and the gas released at the anode is the oxygen gas? In order to find out the answer to this question, collect the gas formed at the cathode in a test tube and close the mouth of the test tube with a cork. Label the test tube as C. Similarly, collect the gas formed at the anode and label it as A. Take the test tube C and bring the lighted matchstick close to the mouth of the test tube C. A pop sound proves that the gas in the test tube C is hydrogen. Now, take out the test tube A and bring the glowing splint close to the mouth of the test tube A. The ignition of the glowing splint proves that the gas in the test tube A is oxygen. So, the compounds can be decomposed by heat or electricity. Sunlight is also a form of energy. Can it also cause decomposition reaction? Yes. When a compound such as silver chloride is placed in the presence of sunlight, it decomposes to silver and chlorine. Decomposition reactions are important for us. These are used in black and white photography, extraction of metals, and manufacture of calcium oxide.